Hello everyone, myself Pavitra. I am here to present my AAT Tech Talk of Chemistry. Today my topic is application for the efficient use of potable water. Abstract and automation water distribution system has been developed to take the best usage from a spring water resource. The automation problem is solved by defining all mechanical and electrical constraints. The problem also consists the default characteristics of situation and needs. The system consists of water source spring, water distribution pipelines, two water tanks, belongs to separate villages and automatic control unit. Now introduction to potable water. To find potable water, which is the first indispensable need of man, is an indisputable fact. A growing population and industrialization cause environment and water pollution. Therefore, the problem of finding clean and drinkable water is one of the most important and emerging problems in the world. Therefore, potable water obtained from the water source most efficient, clean, less energy expenditure of consumption, and also supply to the user is very important. The problem of control of water resources has been the part of environmental, agricultural, economy, and health subjects. The obtained water from source, there are also some problems such as distribution, wasting, and control. Tavers has studied theoretically about water distribution network. He has developed nonlinear dynamical models and controllers to monitor the level of the water in the canal system of NUHCC in Portugal of one. Lemos, etc. all have developed an application of LQG centralized and distributed fault tolerant control to a water delivery canal. In the presence of Actver, Falstaff2, Parker, etc., all have improved a control system based on SCADA, supervisory control and acquisition, for water supply system of urban. This system is a large scale water delivery system, including pumping station, filtering units, storage tanks, piping distribution network, and central dispatch unit. Baume, etc., all have developed models and controllers for irrigation canal systems, characterizing by time delays, nonlinear features, and interactions among subsystems. Corriga, etc., all have used structural Petri-nets for modeling of irrigation canal networks. Because of diverse and comprehensive literature, it was examined only the water canal networks and control of water levels and pressure. In this study, a virtual water resources automation problem is solved by defining all mechanical and electrical constraints. The problem also consists the default characteristics of situation and needs. The system consists of water source spring. Water distribution pipelines transfer water to a factory for use in the production of drinking water. Two water tanks belongs to separate villages to the accumulation of excess water. And automatic control unit. Choice mission algorithm is used for solving the problem electronic platform on which to run the algorithm. The system features expected considering that the unit is divided into different tasks. The characteristics of each unit, tasks, and equipment planned to be used is determined. defined as functional elements of the system with electronic equipment separately tested and where necessary proposing equivalent circuits are designed and manufactured. Hardware platform and the all units brought together is in an experimental manner equivalent circuit of the system can be monitored in real time and transferred to the computer to be observed by the user. Material and methods. Problem. Intended embodiment is a remote monitoring and automatic control system of a water supply. A certain amount of water generated in the total should be primarily forwarded to the factory so that source can be used efficiently in all conditions. Once this condition is met, the water will be stored at equal levels in two separate tanks to use as potable water in residential near the source. After the deployment process, increasing water will be released into the nature again. The problem mentioned above is solved by an automation system controlled by a chance of choice machine algorithm. Modeling of water supply automation system. To village store due to geographical conditions, the main source facility is unable to connect with wired communication is assumed. Therefore, storage nodes placed in the store has to communicate wirelessly by the central control unit. The waterway system to outgoing hotlines for each store to conveyance lines for the plant and one flood hotline to protect the facilities from very high spring flow is made. These five different lines from the water onto the arriving points will be redirected by using the choice mission algorithm. The algorithm will generate commands to control opening and closing of each valve. It is considered that there is a flow meter to measure the water flow rate on each line. A chart of the mechanical structure of the system is shown in figure 1. Now see the figure 1 is mechanical structure of the system. States and conditions of the system. Choice mission algorithm is based on the following system states and conditions to ensure the flow of water as a minimum total 10 liter per hour flow rate in factory line is a priority. The level of water to be transferred to the tank has to be observed continuously. The difference of two tank water level should not be more than 30% of the total volume. A bloodline A floodline must be available in the system. The water level of each tank rises above 95%. The corresponding tank is necessary to disconnect the water supply. If it cannot be got any recent data from any tank will not be supplied. System operations and all measured values will be transmitted to a computer or a mobile device. Mobile devices does not receive data for a certain period to date should try to reconnect. Limits of the system. The water supply can provide maximum 100 liters per second flow rate. Facility is assumed to be strength to sudden changes in water flow. Resistance from inertia and surface effects. Each of the water canal has equal diameter so that the water from the source is divided into equal flow is assumed. The maximum flow rate in each line used in the system allows 40 liters per hour. Valves regulating water flow can be opened and closed quickly enough. Choice mission algorithm. In order to solve the problems described above, operation of the system is simply explained by a flow diagram. Basic inputs and outputs of the system are the flow rate of water supply, water level information of both stores, and the output of all valves open or closed position knowledge respectively. Operation of the system will be provided with the choice mission algorithm. A simple block diagram for this algorithm is shown in figure. This block diagram of choice mission algorithm for the system. Design and implementation of the system. For solving the above mentioned problem, an electronic microcontroller based system has been implemented to collect and interpret the data taken from industrial scenarios, which are scheduled water level and flow rates. The aim of the hardware is to interpret sensor inputs to run the choice mission algorithm to ensure control of the valves and to feed the user interface about the functioning of all process. The elements constituting the hardware platform content and the task are detailed below. Now central controller unit. The main task of the central control unit is to rush the choice mission algorithm. The main task of the central control unit, the choice, is to rush mission algorithm. In order to handle inputs and outputs of this flow is run DNO33 based control code on MSP430F1611 microcontroller located on the SA control card. This is the central control unit. Drain control unit. Drain control unit of the system as a bridge between wired and wireless connections are assumed. It controls all the data being transferred by RF and RS232 protocols. Drain control unit consists of TDAS node, RFV21 and TDAS sync card. This is the silence control unit. Tank nodes. There are two storage nodes in the hardware platform. These nodes controls the level of occupancy of each water tank and the readings obtained with the RF link transfers to the sluice control unit. Tank nodes consist of TEDAS number RFV21 and Presonic TFMU30 ultrasonic level meter. This is tank nodes. User interface unit UIU transmits the knowledge of water levels, flow rates of transmission and flood flows lines and the status of valves to PC, tablet PC or mobile PC. The entire system is electromechanical property. Therefore, for the realization of system flow, electronic hardware platform has to be positioned on the water supply. Mechanical system according to their duties and to be ensured. Integration. Electronic control of the line valves and flow rate meters will be provided by the central control unit. So, this unit is also located in the same building where is water supply sluice control unit communicates with central control unit via RS232 connection. So, it will have to be found close to this unit. Tank notes which they are attached will be found on the tank. All electronic hardware units in the system were individually designed and implemented after passing test. The units were integrated with the mechanical system. The integrated electromechanical system is shown in figure 7. The integrated electromechanical system. Thank you.